Welcome and thank you for joining us for another episode of the Jane Irrigation Training Series. I'm your host, Richard Restuccia, and today we're going to be talking about designing tape, tubing, and emitter line, and really how do you maximize the efficiency of your irrigation using these three products. And I got to be honest with everybody here today. Sometimes I get confused, and it's sometimes hard for me to decide which product I should be using on a particular job. Great news today is that we've got Corey Broad, who is a territory sales manager and product manager for Jane Irrigation, who's going to step us through a process that will make your decision making a whole lot easier and accurate. And accurate is the really important part here. And for those of you who've seen Corey, you know what a great resource he is for all of us in the irrigation world. Corey is a certified crop advisor. He's a certified irrigation designer. He is a certified irrigation specialist, ag irrigation specialist, and so much more. He's really a go-to resource for a lot of Central Valley growers these days. And also does a really good job of promoting sustainability and irrigation efficiency on social media. So I love it when we've got somebody like Corey who's promoting this a lot and all over the place. So Corey, thanks for joining us today.
No, thank you, Richard. I appreciate the opportunity to talk about it. And it's funny that, you and I talk about concepts of things that we want to, work on in the industry. What do we want to promote? And then also, what are our customers asking, whether it's a distributor or an end user, and trying to find, topics that are really relevant. And it's funny in that we've, created this presentation, talking about it together. And then literally yesterday, I have an example of a phone call that I got from a distributor who had some questions. And I was actually able to basically kind of walk them through some of the things that we're going to walk through today. And so it's just super pertinent that these things do come up pretty frequently. And so it was just funny that we kind of spoke it into existence and that it literally happened yesterday afternoon. So again, happy to be here. As Richard, mentioned, there's a big catalog. We've done a lot of these now. I don't know if you have the direct number off the top of your head, but I think this might be my 14th or 15th. And I'm sure we've done 200, maybe 300 now. And so it's an impressive catalog. There's the QR code that's up there. I reuse this slide quite a bit, but also just a link to the trainings if anybody's interested. It is available in podcast and in other formats as well.
Yeah, so Corey, thank you for mentioning the trainings, right? We've had over a couple 100,000 people either attend or watch online. Now, it might be the same people over and over again, because I think there's probably not a couple 100,000 people in irrigation, but nevertheless, they are popular thanks to the good work that you do and the education that you and others deliver. So, Corey, am I the only person who gets a little confused about when to use what tape, right? I mean, because there's different varieties, emitter line. What's this like for people?
It's I think the best way to kind of break it down is, we have such a comprehensive solution just at our company itself. And obviously there's going to be competitors out there too, but we have heavy wall tubing, we have emitter line, we have all these drip tape options. And then we're trying to fit this all into different crops or plants, the applications, the challenges that are surrounded in irrigated ag and landscape. And it's great to have all these choices, but the best way I can say, Richard, is it's just like sending somebody who's never been to the grocery store before to find this very specific one thing. We're overwhelmed by choices. You go and you can have, 5 different flavors of the same thing. And it's like, man, it's almost information overload. And so you think about it, we're fortunate that we have a lot of technical expertise in our building and in our company, and a lot of talented people that we work alongside. But somebody who maybe hasn't done this before, hasn't purchased these products or worked with them, it can be a little bit overwhelming just to look at our catalog alone and say, how do I make my way through this? And again, that's part of what I hope to share today, and what I'll continue to talk about is the people, right? The products are one thing, but having the educated and certified people behind it, I think really, sets it apart. And when I talk about designers and what their tasks are, especially from the agriculture side, we really ask to balance kind of agronomics, plant health, and economics, both on what is the return of that investment from purchasing a product and growing that crop, but what's the cost of it too on the front end. And I really think that value is kind of maximized in full efficiency to where you're looking at the efficiency of the product and the investment, and it's exceeding the budget of what you put in. Because again, in farming, we're trying to make money, and it can be really, really challenging out there. So it's not always just about making money today too. It's about looking at, especially, we talked about almonds on the way in, that's a 20 to 25 year investment. We have to make sure that we understand the full scope of ownership in that process.
Yeah, great points, Corey. And then, for all the growers out there, right, they have to figure out what tape goes with what they're growing, what they are growing. So that's one issue. And then there's variations in tape. And so it's two variables here, I think, that make it a little bit more difficult.
And then there's an exponent, and then another variable, and then a fraction, and it gets really complicated. But no, you are certainly spot on, and not the only one. And so I mean, kind of to what I was just saying, I mean, this is just a screenshot I pulled from the catalog. This is just our heavy wall tubing section in our catalog. And again, I talked about having this robust, comprehensive line of irrigation tubing, or what we would call supply tubing. There's a lot of different things to unpack here. And again, it could be overwhelming if you're not sure what you're looking at, or again, what might be the best fit for what you're trying to do. And so we don't need to focus too much on the details of it, but I just kind of wanted just to, again, kind of slap it out there that, hey, this is, what we have to face every day. And so you have a lot of different choices here. Obviously in agriculture, we kind of have most of what we do down to really 3 common sizes, which is nominally referred to as a 1/2 inch, 5/8, and 3/4. But if you're on the technical side of it, it's 620 by 710, 720 by 820, and 830 by 940. There's obviously going to be smaller versions and larger versions outside of those specs, but it really kind of comes down to, for an example, if you're using a pressure compensating emission device, say a click tiff button dripper, you might be able to use smaller supply tubing, smaller lateral tubing, in order to save money, because that device is putting out the same amount of water across a wide pressure range. And we'll talk about that more here in a moment. If you're using a non-regulated device, say like a Jane Jet, which does also come in pressure compensating, but if you're just using the simplest version of that product, pressure loss will likely affect the emitter flow performance. So less pressure means less flow. And so with really long runs on short tubing, you may actually see a massive degradation in the uniformity of that product. And you've still invested money, even though it was less, and really not be able to capitalize on the return of that investment that was made.
That's a great point, Corey. And the one thing I always think about is if I didn't know that, or if I didn't watch you today and learn that, how would I know that?
Partner with certified people. I think the Irrigation Association does a great job. Obviously, I'm a little biased being involved in the Irrigation Association and actually being on the certification board now. But there's tons of licensed certified professionals that you can find on the website to say, wow, this might be somebody that I want to partner with. And again, that Rolodex, if you will, is publicly available. I would just seek out people with experience and people with certification.
Yeah, and this really is a lot of this is engineering, right? This is using formulas and getting it right, and so having that background is really key.
Absolutely. And so just to kind of break down what we were just talking about, just graphically, I've taken this from a number of presentations in the past, and what really we're illustrating here is kind of uniformity versus pressure. So if you had a non-regulated device, so again, say a Jane Jet, or even a non-regulated dripper, which is available. You see on the left-hand side, kind of the pipe segment, and then it feeds down the row to the right-hand side. And essentially in this example, all the way down the lateral, it's basically 16 pounds of pressure. Therefore, you have that nice uniform kind of blue box of water, if you will. And every plant is well watered, and it's pretty easy to manage, and we know how deep it's going to go, so on and so forth. Everything's good. Now, in an example where you had what we would define as excessive pressure loss, so you started with 16, and instead of ending with 16, you're now ending with 6.5, so you can say roughly 10 pounds of pressure loss. you see that the front plants are pretty well irrigated to about a third of the way. Then those other plants in the middle are kind of like, I'm not, totally happy. And then probably the last few plants are not looking too hot, right? And it doesn't matter if it's a rose bush or if it's an almond tree, they're not getting what they need. Especially you start thinking about from the ag side where we do fertigation, they're not getting the nutrients they need. It's an exponential compounding effect. That's just an illustration of what happens where you have too much pressure loss in a line. And now that could be because we use too small of a tubing in order to meet the flow demand, or it could be that we just ran the tubing too far and didn't have manageable run lengths. And again, the example that I got handed yesterday was, hey, I need your expertise. I have a question. And I said, okay. And they said, I have a grower that has 8-gallon-an-hour sprinklers, and they're spaced at, I don't remember off the top of my head, but just say, 15 feet apart. And they want to know how far they can run that. And I said, well, it depends. And they go, what do you mean? And I said, well, we can run it farther if we use larger tubing because there's, more area, there's less friction loss inside of it. I said, so that's one option, which to a certain extent, there's a terminal end. And then I said, the other option could be that, we could run less sprinklers or try and change the flow rate of the sprinkler in order to lower the amount. So you just work through these things with them. And what we ended up doing and deciding at the end is the proposed run length that they wanted, they needed to cut it in half because they told me, I want to use 1-inch tubing.
Yeah.
And I said, why is that? And they go, because they already have that in a field next to it. And I said, okay, well then now I've been defined on what product we want to use. So that big list that we looked at earlier kind of got shrunk down to one SKU. This is the product we want to use. Okay, well now we're bound by that. So in order to not have a graphical representation in your field like we have up here on the screen, I need you to run it essentially half the distance that you thought you were going to be able to. But that just comes through, again, knowing those formulas, using our resources, which I'll go into some of those later on, and having that experience and saying, hey, this is the correct way to do it. And here's the result that you're going to get.
Yes. So comment and a question. First comment is, gee, this illustration, I've never seen something that looked like this, right? Usually the distribution uniformity is a little different, but boy, this really gets the point across that if you don't have pressure compensating emitters, you're going to have a problem.
You can. It just means you have to design the system that much more efficiently. And we'll go into some of those kind of nuances here in a moment with the numbers of it. But I can tell you that there are orchards that if you look at the sunset behind it and you're able to get in an elevated position, the trees grow like this. In the center of it, they're all big and healthy. And at the end, it goes down. And it's because the system maybe hasn't been maintained or wasn't designed properly. And therefore, the end has less pressure and the trees are just 10% smaller.
Yeah. And so then the question, does Jane have a tool that helps people understand this?
There is our length of run calculator. I will kind of break out a couple examples on that and have a link to it. Also in, like, for instance, for our supply tubing in our catalog, we actually have all of those different sizes that I talked about earlier, and then different flow curves. So at 1 gallon a minute, at 100 foot, so on and so forth, that you can go through and you can say, oh, I have an idea that I'm going to run this 300 feet. And then Richard could be at home. He could look at it and he could go, yeah, that's probably not a good idea. Or, oh no, that looks like it works just fine. So there are tons of resources there. So the supply tubing catalog has a lot of graphical information in there and tables. And then our length of run calculator we'll look at here in a bit is also great for tape and emitter line.
Yeah. Okay, great. Thank you, Corey. And I just want to remind everybody that I do have the chat and the Q&A open. So if you've got a comment or a question, put them in there and I'll get them to Corey as soon as I can.
And I forgot one kind of final note on this. So if you wanted to make the last plants in the row very happy, so in order to get that adequate amount of water, which is kind of where that dashed line is, you end up having to over irrigate, 7/8 of the field in order to keep the last 1/8 of the field happy. That's kind of the rule of distribution uniformity. And so that, again, is just a gross example of, well, now I have to over irrigate. Well, then that might throw off the nutrient balance on the front end of the orchard. And so there's just all of these things that go into play. So Let's try and get to the first example where everything's really even and really nice. And again, work with the right products out of the gate. So getting into a real life example, things that I see out in the field. This is a flow chart from one of our JaneJet catalogs. And so I chose a number 35 orange nozzle, pretty standard spec that we see even in almonds, but also in citrus. And in this case, I chose citrus. It's a 20-foot row spacing with an 18-foot tree spacing. And our lateral run is going to be 330 foot long. So from the riser to the terminal end of the hose will be 330 feet, which is pretty standard for us commercially here. If I say that I have a nominal spec of 20 PSI at the riser, and I go and I run that 330 feet with one jet at 8 gallons an hour, or 8.4 in this case, every 18 feet, so one per tree, again, very standard to what we do. If I use a 720 by 820 tubing, so a 0.720 inches inside diameter, I'll lose about 1.7 PSI down that run. If I go down to the next size smaller, which for Jane's offering is a 620 inside diameter, so I just shrunk it a little bit more, I'm going to essentially double that. It's 3.6 PSI of loss. Both of those are probably acceptable, but let's work through the scenario together. Just on a numerical basis, in the 720 tubing, we're going to lose about 8.5% of our nominal spec PSI. We lost 8.5% of 20 PSI in that run. It's 18% when you use 620 tubing. So, okay, that number jumps out and you're going, okay, well, what does that mean to me? Remember that flow and pressure are directly correlated in non-compensating emission devices. And so a loss in pressure results in a loss in flow. So to break down this example kind of in a more gross manner, if you see the red circle there, I have it on 20 PSI at 8.4 gallons an hour. If I go down to 15 PSI, it's 7.3 gallons an hour. That's a 25% loss in PSI, is a 13% loss in flow, which is a degradation in uniformity. The trees at the end of this row, if I lose 5 pounds of pressure, will receive 13% less water.
Yeah. Wow. That's a significant amount, especially if you think about it in percentages too of this could make a drastic difference in how your plants look or your trees look.
Because at first we look at it, right? And we go, well, it's 5 PSI. Okay. Well, that's 13%, right, on your flow curve. And then you go, well, how many inches of water do I pump a year? And you start adding up that amount and you go, wow, okay, that's a big difference. And then you think about how much nitrogen you might apply and other products, calcium, and all of a sudden go, oh, wow, that directly hits my bottom line. And this is how it impacts me economically. So that's where I, again, tie in the agronomics and the economics. They're generally pretty closely related.
Yeah, and then the other interesting point I think about this is that maybe it takes you a little extra time at the beginning to figure this out, or an extra phone call to you to figure it out, but it impacts every irrigation for the season.
Absolutely. And the next one and the next season. And, it's because, I mean, we're talking about tubing that, we want to see last 15 to 20 years.
Yeah.
We're talking about a crop that we want to see last 20 to 40 years, depending on what you're planting. So yeah, it's a little bit of detail up front can go a long ways.
Yeah. Yeah. Or I'm definitely making that phone call to you.
Exactly. So kind of, trying to draw some similarities and just kind of showing a pressure compensating difference. So this is a 2002 micro sprinkler from Jane Irrigation. And I chose a flow that was somewhat close. This is 9.3 gallons an hour. So it's technically a little bit more. But let's just use that same scenario just to kind of show the difference there. These sprinklers run at a tad bit more pressure, but the 9.3 gallon an hour spec is at 25 PSI. So if we use the 720 tubing, we lose 2 pounds of pressure. And if we use the 620 tubing, we're going to, again, about double that to 4.3 PSI. So using a larger tubing, it's 8 PSI of our nominal hose spec at 25. If we go to 620 tubing, save a little bit of money, that's 17% of our PSI in the hose run. Now remember that pressure and flow are directly correlated, but PC eliminates or reduces the PSI to flow ratio. And so in this example, a 20% loss in PSI going from 25 to 20 results in a 2% loss in flow, which in my mind is negligible. There's more errors in irrigation scheduling and maintenance and all the other inefficiencies in working in outdoor large scale agriculture, that the 2% is really kind of minute, because the flow rate only changes from 9.3 gallons an hour to 9.1. That is the power of using a pressure compensating low exponent emitter device.
Okay, so yeah, you said PC earlier, but that is the difference here. It's the pressure compensation.
Absolutely. So we can still lose 5 pounds and 2% loss in flow versus 13.
Yeah. Yeah.
So
Again, think of that in percentages too, and it's significant, huge.
absolutely. So we've kind of covered supply tubing, right? Again, this is tubing that doesn't have any emission device built into it. It's so that we can connect it to emission devices like those sprinklers we talked about. Maybe put our barbed adapters or put a button dripper like our click tiff on there. It is supplying water to an emission device. When we talk about emitter line, because people will talk about drip tubing also, is probably what people are mostly referring to, but the technical term for emitter line comes from, it is supply tubing with an emitter built into it. It has an emitter welded inside of it. And for us at Jane, that's Amnon or Top Drip. And those are both pressure compensating emitters. And what's really neat about this also is that it comes in a wide range of sizes. So we tend to talk about it in millimeters, kind of in general terms, so 16 all the way up to 22. But also it's important to know the inside diameter and the outside diameter of those. And one thing that's really unique to Jane is you take, for instance, the 17 millimeter option, with the 570 inside diameter. We actually developed a fitting because we sell fittings into the market and are one of the leaders in that space, that we have a coupler specially designed for that size hose. Very few other people can say that they have that specific size, but also the fittings to go along with it. And so I think that's an important differentiator, that we have all of these options and we have all the fittings and accessories to fit those options. Because I could come up with a really good idea, but if I have no way to put it all together, it really won't matter.
Yeah, that's a great point, Corey, because again, you shouldn't have to know, okay, I've got this emitter line, so what size coupling do I use with that, or what power lock? You'll want to cover many.
Yeah, exactly. And so again, we have all the fittings and accessories to fit that. And so that's, again, value added, because kind of the one-stop shop approach. But what's really important about each of these size emitter lines is, there's more common ones, which would be 18 and 20. But I mean, I've sold plenty of 22 millimeter, and I've sold plenty all the way down to where we can really fit what is the designer trying to achieve, what's going to be the most economical value, and what brings the most agronomic value by picking the right one. And you can size this irrigation system and really change it just based on changing the size of the emitter line. And so again, we're one of the few people in the marketplace that can do this. So that's why I always encourage people to look at these products and kind of have this in the back pocket of designers, because it allows them a lot of flexibility where they're not kind of handcuffed to maybe one or two sizes. And then, well, I'm sorry, I have to add another line kind of scenario.
Yeah, so I'm getting it. I'm starting to appreciate choice.
Yeah, exactly. Guided choice. So kind of going down again with Amnon and Top Drip, they're PC, so really designers can limit capital costs without sacrificing that agronomic benefit. So hopefully, you're still getting that same output of water that we talked about, because it's kind of reducing the effects of pressure loss to a certain extent. But again, maybe I can lay out a field differently that becomes more user-friendly, or can limit cost up front for the grower. Those longer hose runs can be achieved using those larger diameter tubings that we talked about. And then that allows you to run more tubing, which it was going to exist anyways, the lateral length. But now maybe I'm cutting out trenching and PVC manifolds and riser connections and fittings and installation time, because it's kind of a net even on installing the tubing anyways, because it had to be out there. So these are just kind of the things that irrigation companies get the opportunity to look at. And then hopefully that can trickle down to the grower as a more cost-effective system. And then hopefully something that, has a quicker ROI. It is important to note, and we'll go into this, larger diameter hoses still require proper design though, to make sure that you have minimum operating PSI at the end of the laterals. Just because you made a choice to go, oh, I'm just going to go really, really big and I shouldn't have a problem. there still needs to be some of those formulas that you referenced earlier.
Yeah. So Corey, we have our first question coming in from a viewer, and I think it's a good one, and it's one I've heard before. And the question is about this. Sometimes my local supplier has your fittings, but not your tubing, or vice versa. What do I do about this?
Well, first we would hope that you could request Jane with whoever's there. I think as a sales guy, that would be my favorite thing. But obviously, it's important to ask them their expertise and how those things are going to go together. I think that obviously we have our full suite of catalogs, and they have all of our technical information is publicly available. So hopefully you could make, an informed decision on your own if maybe the distributor or dealer doesn't have that information readily available. I would say that most of them do. The great thing about Powerlock fittings is, again, we have that wide range that I talked about, but it's very agnostic. You can buy a Powerlock coupler and you can use it on our product, and you can use it on our competitor's product. Obviously, we hope that those two go together. But just because you maybe have one of our competitors' products doesn't mean that you can't use ours. It's agnostic.
Is the inverse true? Do the other competitor products work on ours, or is that unique to Powerlocks?
I would say that our tolerances are a pretty wide range. Most of our competitors have kind of followed suit in that pursuit. But I would say that as a fitting company first, as kind of we came to be as a company, we've really done a good job of finding the right fits for what are growers using, what are contractors using, what are dealers using. Okay, what product can we make that'll cover as many as possible? Because I don't want you to only have a coupler that can only be used with one specific size. I need to give you a little bit of flexibility in there. But most of it is pretty agnostic.
Yeah. Okay. And then have you ever heard of a dealer that if you said, hey, I want to order the Jane tubing, and they say we don't have it in stock, and well, can you order it for me? They'll do it, right?
They will. I mean, I think that if they're an authorized dealer for Jane products, I talked about the people, right? I'm just one person in a very large team. And the people that you and I get to work with every day, Richard, are super talented, super passionate about what they do. And I know that any dealer that wants to interact with us, any distributor that wants to interact with us is going to have a positive experience. And so I'm very confident in saying that, yeah, if they are an authorized distributor of our product, we would love to talk to them.
Yeah. Okay, great. Thank you.
Absolutely. So I talked about making sure that it still has pressure at the end of the line. This is an example where somebody said, hey, we're having issues with the product out in the field. I'm like, what's going on? They said, there's no water coming out. And I said, well, that's unfortunate, because that's what we would hope that it would do. So I went out there and I said, hey, do you have a pressure gauge? And they said, yeah. And I said, why don't you put it on the end of the hose? And that's the pressure that we had at the end of the line. So therefore there is no flow. So we talked about those longer lateral runs, but to a certain extent, you can only go so far physically without having some, ridiculous pressure requirement. And so those longer lateral runs are great, but you're probably going to have an increased pressure demand also. If that pressure requirement is raised to operate the system regularly, so say we needed to add another 10 pounds of pressure to this irrigation system, that just makes the operating cost that much more expensive. It makes your vehicle, quote, less fuel efficient, right? I'm having to use more energy, which in most of our cases, electricity, in order to achieve this kind of desired effect. And so upfront, it might be cheaper, but if I give you a 20-year cost of ownership and I say, Richard, this is $10,000 cheaper, but in 20 years, it's going to cost you $20,000 more. Time value of money, you can work that one out pretty quick, and your decision might change. A rule of thumb is, again, 1 PSI is about $2 per acre per year. So if you have a 40-acre irrigation system and you want to raise that extra 10 PSI that I just talked about, and then think about owning it for 20 years, you go, wow, I think I need to make an investment on a more efficient system. So we can push things to the envelope, but let's also make sure that we keep our eye on the prize of what's that cost of ownership. What size should that main line be? And then in this case, what size maybe could that tubing or emitter line be? And
Yeah.
don't trip over, dollars for pennies, right? You can save some money up front. It gives you flexibility, but also don't get caught on the wrong side of that curve.
I love this one PSI equals $2 per acre per year. Hadn't seen that before. That's really helpful. So Corey, we've got another question coming in about pressure compensation. And if I'm running my drip lines through valleys or, not completely flat terrain, does it still work?
Yes and no. It depends is my favorite answer. I would say that it will work as long as it meets the minimum operating pressure. So that's generally what we run into is when you come back up the hill, if it's losing too much pressure due to elevation, you could fall outside the curve. So you take like Amnon, for example, that has an operating range of 7 to 60 PSI. I think top trip is like 6 to 58. They're very similar. But that's a very wide range of pressures. So if the system is normally running at 30 and you lose a few pounds of pressure going uphill, it's not a big deal. And then maybe you gain a few going back downhill, you're still kind of in there. That's really important for the designers to be able to spec and lay out the system so that, these uh, factors of elevation don't get in the way. But yeah, as long as you're within those two numbers on the high and the low, you're going to be just fine. One thing I will say that's also important to consider is, yeah, the emitters are working fine while the irrigation system is on. But if you have a valley and then you have these low spots and you turn the irrigation system off, all the water that's been at the top is going to drain down to the bottom. And we see this a lot in the vineyard market in the coastal areas of California, where they would like to have what we call CNL technology, check non-leak or close non-leak, which effectively that emitter shuts at 3.5 PSI and doesn't allow the water to drain out. So there'll be a little bit of drain down that goes on when you first turn it off, but instead of 100% of that line draining into the low area, it might only be 10% of it.
Yeah.
And it's a unique characteristic. It's something that really us and only a few other people have commercially available.
Yeah, that's a great point. And yeah, you just solved a lot of problems for people.
Hope so.
But the big variability in this is how steep the hills are.
Absolutely. And that's, again, that's where I go to that experience and that certified individual to be able to look at it and say, okay, this is how far I can run this, but also here's the challenges that I'm going to come to. Fortunately, Fresno's pretty flat, so it makes things pretty easy around here, but that's not the case in many areas that are irrigated.
Right. Yeah. And you mentioned the vineyards. I mean, what comes to
Ex-
mind right away?
Exactly. So I talked about resources earlier and length of run calculator. I have the link up here. It's pretty easy to find on our website under resources. It's a free online resource. Anybody can use it, and it's really good for emitter line and tape lateral sizing. So in this particular instance, I just kind of showing, I chose an emitter line in this example. All I did was enter 20 pounds of pressure at the inlet side and then clicked calculate. And there's a few other things you could include if you wanted to, but essentially here you can see I start with 20 and then you can see my ending pressure and it's calculated in 100-foot segments. So there's basically no pressure loss in 100 feet. There's 200 feet, less than a pound. You could see the curve starts to change though, because you go from 19 to 18 to 16, so on and so forth. This is your ending pressure. So in this case, you might have, just about 4 pounds of loss. This one all of a sudden becomes significantly more, and it's kind of a hockey stick curve. So you can kind of sit there and go, at your property, hey, I wanted to run this 500 feet. Oh, okay, 4 pounds of pressure. I know I could supply 20 pounds, then we're good. If you said, I want to run it 800 pounds, or excuse me, 800 feet. Well, now all of a sudden I talked about that minimum operating pressure. I'm outside the curve now. I'm at 5 PSI at the end of that line. Okay, well, I have two options. I either pick a bigger line diameter, I shorten the run length, or I increase the pressure on the front side. And again, this is what the balance of what designers get to do every day is decide, okay, well, what's the best case? Well, cost of ownership, it's probably not raising the pressure because I got to put in a bigger pump and do all these other things. If I say, hey, Richard, this is going to be a little bit more upfront because I'm going to use a larger tubing, but your cost of ownership is lower. It's my job as, again, a certified individual to have that conversation with you and say, hey, these are the things that we're doing and why we're doing it.
Yeah, so you do have three options, but really in a lot of cases, the least expensive option is going to be to increase the size of your tubing.
Right. Because again, it may be upfront more expensive, but in the long run, you're gonna go, wow, that was a much better choice.
Right. And Corey, a lot of people think they're saving money right by downsizing their tubing. What do you have to say to them?
You certainly can. I think it's also situational, that you have to sit there and you have to work with somebody as a trusted advisor to say, the difference between one size of tubing to the next might be just say $15 a roll. Well, if I have a double line drip system in almonds, that's about 4 rolls per acre, $15 per roll difference, $60 an acre. Well, when you have $10,000 an acre and, removing vines and replanting trees and putting in an irrigation system and doing all this stuff, $60 doesn't seem like much, but you've just spent a lot also. So you're a little sensitive maybe. And you sit there and go, okay, well, I don't really know if I need that. But then I sit there and I say, Richard, you need to have more piping if we go with smaller tubing. I can't cross the field once, I have to cross it twice.
Hmm.
And you go, okay. And I said, well, that's twice as much trenching for me, and it's twice as many risers. And then also when you go to flush it, there's twice as many hose ends. And so again, it's about working through that balance with somebody that has that experience to say, here's the pros and cons to each of these decisions. And my job is to maximize the value for you as a grower.
Yeah. Yeah, that's great. That really helps, right? Stepping through that thought process. Thank you.
Absolutely. So kind of getting into the drip tape portion and what I would say is perhaps the most sensitive product to size. Jane still offers a really comprehensive line of drip tape sizes, emitter styles, and tube builds. Again, we have our Chapin, our Cascade, and our Turbo Tape kind of models, if you will. Those are kind of our three distinct lines, and they're all super unique in their flow path and emitter styles. Chapin and Turbo Tape are going to kind of continuous flow path. Everything from ultra low flow up to really high flow products, and they're really available in that traditional 5/8 and 7/8 sizes, where Cascade still has 5/8 and 7/8, but also has 1 inch, 1 1/8, and 1 3/8, because it has a discrete emitter welded inside of it, kind of almost similar to Amnon and Top Drip earlier. It's what we would almost identify as a thin wall emitter line, but as we talked about earlier, because it's used in corn and cotton and tomatoes and all these things, it kind of gets lumped in with drip tape because of the commodities or the agricultural goods that it serves.
So if I'm getting this right today, if I'm thinking about really long runs, I'll probably be thinking Cascade.
Generally, yes. Because again, I have the option of changing the flow of the emitter, moving the spacing of the emitter, or changing the size of the tubing.
Yeah.
And so it Cascade predominantly gets sold in the Midwest portion of the country, where they do half-mile runs,
Yeah.
because of the way that their infrastructure and layout is, where here we're doing a lot of quarter-mile runs that will use a lot of 7/8 tape. So just depends on kind of what the fit of the land is. I talk about it being the most sensitive to size due to longer lateral runs. So where most of our orchards are 330 to 660 foot supply tubing and emitter line runs, most of our drip tape applications here, especially in the Central Valley, are a quarter mile or roughly 1,300 feet, so I'll double. And most drip tape flow rates are specified at 10 psi of operating pressure, with emitter line running generally around 15 to 20, and then sprinklers kind of in the 20 to 30 range. And so if we again break this down numerically, 1 psi loss in drip tape could be 8 to 10% of your nominal flow rate. Whereas that same amount, that 1 psi, might be 5% in emitter line or 3% in sprinklers. So getting it right in drip tape is super important because the tolerances are so much tighter. And with that, drip tape is almost exclusively non-PC due to cost and style of the products. It's really hard to weld a PC emitter in a very, very thin wall product. Therefore, there are some PC drip tape options, but it might be available in a 20 mil thick product instead of a 6 mil product. Well, if I'm growing corn and I'm only keeping it in the field for 1 year, I don't want to buy a 25 mil thick product. Economically, I can just never make that work. So that lack of PC really requires strict design procedures to make sure that water is uniform, and it's a uniform across the field and manifold in the block. Sizing drip tape is important, but selecting the mill thickness is important. So I just talked about kind of a use case example of, a single use seasonal tape being 5 mil or 6 mil, and then a kind of a longer term tape being all the way up to 25 mil option. Most of what we use here in the Central Valley is going to be anywhere from a 5 mil to a 15 mil. There's very few use cases of this really, really heavy stuff. And there's some on the very, very thin side, but thinking about it going into corn, cotton, tomatoes, celery, lettuce, you name it, all these field crops, they're only in the ground for sometimes 88 days, sometimes, just 2/3 of the year. Whereas if I go and I put a hose out in an orchard, it's going to be there for 20 years. It needs some flexibility, and it can't be super thick, because the thicker the product, the more expensive it is.
Yeah, that's interesting, right? Because like you said, on the high side, it's not even a 1/2 inch.
Exactly. And so it's very important to get this right. And I really think about the mill thickness, not just on the durability of the product, but also how you can maintain it. You know that I've done a number of these series on maintenance, because it's something that I'm passionate about. But so if you kind of work through this if then statement with me that I kind of made here, if you're going to have a longer lateral run, you need to have a larger diameter size. The tubing or tape has to be larger. Well, now you have a longer lateral run, you're going to have a larger pressure requirement to flush, to make sure that water is coming out the end at proper velocity. So we have a larger run, we have a bigger tube, but now we need to have more pressure in order to evacuate all the debris at the minimum velocity. That larger PSI requirement means that the product has to be thicker in order to handle it so it doesn't burst. So one good deed does not go unpunished in this case. If you look at this picture on the left-hand side, that is one of our flush valves flushing a drip tape field. I can tell you that that is not flushing at the minimum velocity. We like to see 1.5 to 2 feet per second velocity, which in the cases that I'll show you here in a moment require anywhere from like 15 to 30 pounds of pressure. This is flushing at like 6. And so when a grower says, yeah, I flushed my field last week, well, that's what you end up getting is chocolate milk out of the end, because it just didn't do anything to remove that debris. And I've gone through that in some other presentations. But I do see a lot of systems that don't account for that flushing requirement, and quite frankly, don't even have the pressure and flow capable of providing an adequate flush. And that, again, can kind of go back into some of my other presentations. So I showed the length of run calculator earlier. This is kind of the full screen that you would see on our website. And down at the bottom, there's a flushing tab. So you can see I selected 1.5 feet per second velocity. We only give you 2 options, which is 1.5 and 2, because those are kind of industry standards. But I'm using a Cascade 7/8 tape diameter, 14-inch emitter spacing with a 0.17 gallon an hour. I'm running at that kind of 1/4 mile we talked about at 1,280 feet. And you can see that, normal operating, I lose about 4 pounds of pressure. It's 93% uniform. Tells me my average flow rates, gives me a lot of information, but tells me, yep, you're pretty much good to go. But if I go and I plug in 1.5 feet per second on this, I need almost 17 pounds of pressure at the end of the line in order to, or excuse me, at the beginning of the line in order to get my correct velocity at the end. So you sit there and you go, well, why is that important? If I change it to 2 feet per second velocity, it's now 28.5 pounds of pressure in order to adequately flush that line. So if I have excessive amounts of debris and I need that extra velocity to move it, I need the product to be able to handle 28.5 pounds of pressure. Here is a screenshot again out of our catalog. All of this stuff is publicly available. And you look at, we were talking about a 7/8 inch tape earlier. You can see over here, max operating pressure, but also max flushing pressure. I talked about 28.5 pounds. Well, 13 mil is actually going to be the product that I would need to specify in this case. If I wanted to use a 7/8 6 mil product, I could probably use it just fine. I just may not be able to flush at that higher rate, which may or may not be an issue. I talked about 6 mil only being in the ground for 88 to, days to a few months. So maybe it's something where if it degrades at a slow rate and I just flush it kind of at the minimum and I get by, I'm pulling it out anyways. But if I go and I bury something in the ground for 3, 4, 5 years, I need to make sure that it's a thicker product, not just for that durability, but for the ability to be able to say, wow, Richard, we got into some bad water and I really need to get this debris out. And I know that my product can handle that without bursting. So those are the considerations. And where I see the mistake get made often is growers might get into that 10 mil product where they say, well, it's 2 to 3 year product, I'm just going to go 10 mil. Well, you might actually want to consider just jumping up to 13. It's going to be a stronger product when you go to install it. It's going to be a stronger product when you go to remove it, but also you can guarantee that you're going to be able to flush it at the right velocity.
That's a lot of great information there, Corey. Thank you. So we have another viewer, and he's asking about drip tape and emitter line. And your one, the chocolate milk picture looked like this was buried. Can you go subsurface with any of these products?
Absolutely. So if I back up to the Amnon and Top Drip, those come in anti-siphon standard. So it has anti-siphon, anti-suckback technology built into it. Drip tape is almost exclusively underground. There are some instances where we do kind of surface drip type, thinner mill, seasonal applications, but almost all of the drip tape that we do sell actually does get buried anywhere from 3 inches to 14 inches underground. And what's really important about that is just make sure you have the right air vent size, the right air vent placement. I think that was one of the first webinars I did a couple years ago. So please refer back to that one because the issue can be is that you can actually pull material back into the emitter line if you don't have the appropriate air and vacuum relief. I can tell you that in that example with it being buried, that was not the issue. That is not why there was chocolate milk in it. That all came from very poor water quality, perhaps undersized filtration, but more importantly, improper flushing procedures. And procedures are duration and timing and velocity, right? If you can kind of go through how often do I need to flush, how hard do I need to flush that system, and how long do I do that for? If you get that right, you won't have those examples that I just showed.
Yeah. So, and yeah, the air vents, one of our most popular trainings, certainly maybe surprising to some that was so popular, but the right vent and the right placement is key. And you did a really good job getting those points across.
I appreciate that. And if I kind of wrap it up as I do in most of my talks and trying to do a summary is, larger tubing can allow for longer lateral runs, potentially decreasing overall infrastructure costs. PC emission devices can be used to decrease the tubing size, like we talked about, which can save capital investment on the front end. Jane, Amnon, and Top Drip are pressure compensating and have that large PSI operating range I talked about earlier, allowing for maximum capital cost savings. And then drip tape is most sensitive to PSI changes due to low operating pressure conditions compared to those emitter line and sprinkler examples that I've shown. So there's a lot of flexibility in the products we offer, very robust catalog offering. But again, we have really qualified and experienced people on our staff to help you. And then a number of our distributors obviously have those same people as well. So there's help out there. Just ask for it, ask the right questions. Obviously, if you came here, I think you're in the right place. So that's my summary.
Yeah. Wow, Corey, thank you so much. What a great job you did, right? Helping us all understand the differences in these products, and more importantly, showing us some resources to help us learn what the right product is for our application. And then more importantly, offering up your services to help people understand that they can call you, they can reach out to you whenever they want, and you're more than happy to help.
Absolutely. Try and be the easiest guy to find. So as you talked about, I'm on social media, I'm on all these different platforms. So we're always happy to help.
Yeah. So great. Well, thank you, Corey. Great job. Really appreciate it. I want to say thank you to all the viewers. Really appreciate you taking some of your time during your busy day to educate yourselves about water conservation and proper irrigation, efficient irrigation. Remember, you can see all our trainings at janesusa.com/trainings. We've got about almost 300 of them in there now over the past 3 years. Really good quality information, as well as wherever you listen to your favorite podcast. We extract all the audio out of these, put them on podcasts so that you can listen while you're working. And it's always very exciting to me to think that people are educating themselves while they're working. What a great combination. So again, thanks to all of you. Thank you, Corey. And we'll see everybody back here next week on Wednesday. We're going to be talking about how to get your trees in shape for springtime. So it should be a good one. All right. Thanks, Corey.
Thanks, everyone.